Hi, everybody. Just wanted to help wrap up this science unit that we just completed. So, you should have done all five mysteries. We have a test on Wednesday. So, I just wanted to give just a quick review, maybe some ideas about what is going to show up on the test so that you feel like you're ready. Our first mystery was with the pennies, the darkened pennies, and we tried different substances to see if we could get them cleaned up. And some of you in your end of mystery thought that the pennies were dirty and that it was dirt that was being removed. And you got to remember, if it were just dirt, the soap would have cleaned them off, right? We figured out that when the copper of the pennies is exposed to the air, it oxidizes. Remember that word from oxygen? So it's exposed to oxygen. And that's what made the pennies dark. The salt and vinegar reacted to that oxidation and removed it. Okay. So remember when they weighed the pennies in the video? Um, the pennies were heavier while they were still brown with that oxidation. But after they were soaked in the vinegar and water, they weighed less, not a lot less, but they weighed less. So, what happened to the pennies that made them weigh less? Okay, the oxidized material, that oxidized copper, was removed and it was left inside that salt and water solution, which is why when we put the nail in it and soaked it in that same solution, the nail didn't get dirty. It had the copper attached to it, right? So you could figure that if the pennies got lighter after the oxidation was removed, the salt and vinegar water did what? It must have gotten a little bit heavier. So, for as much weight as the pennies lost, the vinegar and salt solution would have gone up, right? Because that had to go somewhere. What came off the pennies, it didn't just disappear. It didn't just, float off into the air. Okay. It did float off into the vinegar and salt solution. The particles were too small for our eyes to see, but they were still there. So as the pennies lose their oxidation, it's going to go into the vinegar and water, right? And that's what their whole weighing the pennies showed us. Now, think of that in terms of like sugar. So they also showed us like the sugar dissolving into the tea. Okay. The tea has a weight and the sugar has a weight. And just because the sugar dissolved doesn't mean that the sugar lost its weight. Okay. It just changed. So once you add the sugar to the tea, the weight of the tea is going to go up by the weight of the sugar, right? So if you had 8 ounces of tea and half an ounce of sugar, when you put the sugar in the tea and you stir it all up, and it doesn't look like it got any more, but if you were to weigh it, you would have the 8 ounces of tea plus the half ounce of sugar. So you'd go up to 8.5 ounces. Half ounce of sugar is a lot. Anyhow, but that gave you the idea, right? So if you are dissolving, it doesn't mean, again, the sugar is not disappearing, it's changing its state. Okay, so it's no longer in a state that we can see, it has dissolved. But what does it do to the tea? It makes it sweeter, right? So the sugar didn't go away. We can tell it didn't go away because we can taste the difference. So if you add a teaspoon of sugar to your tea, it's going to taste sweeter. If you add 2 teaspoons of sugar, it's going to weigh even more than 1 teaspoon, and it's going to taste even sweeter because it has more sugar in it, right? So the weight doesn't change just because it dissolves. Don't let that fool you. Okay. It has changed state, it has not changed its weight at all. So the tea plus the sugar, you're going to have to add them together, right, to get the total weight. Um, so this dissolving makes the sugar become particles that is too hard for our eyes to see, but the sugar is still there, and we know it because we can taste it. Okay. Um, Next was we talked about putting the nail in, and remember that showed that it wasn't just dirt, otherwise would have just been dirt collecting on the nail, right? So there is the oxidation, so the copper, um, I'm sorry, showed up on the nail. Okay, let me make sure I'm doing this right. Now let's think about third the third mystery we did. Okay, the third mystery we did, we had the baking soda, we had the um, purple liquid. Okay, and as we were mixing things, we were trying to test to see whether or not it was a good acid test. So we had baking soda, purple liquid, and baking powder. Sorry. So the remember when we mixed we were trying to see what could we use to test to see if something was an acid. Okay, and so we knew that vinegar was an acid and water is not. Okay, so that's how we were conducting our test. So we took the baking soda, and when we mixed it with the water, nothing happened, right? But when we mixed it with the vinegar, we got this reaction. So baking soda made a good tester for um, to see if something was an acid, which we saw again the next mystery when we mixed it with the ketchup. Remember, ketchup has tomato, which is acid. It also has vinegar in it, which is acid. And so that's why the baking soda fizzed up. Okay. So then the purple liquid, remember how when we tested it with water, it just diluted a little bit. But when we tested it against the acid, it turned pink, right? So we decided the purple liquid was a good test to see um, if it was an acid or not. And then, for me, the surprising one is when we used the baking soda. Remember the baking soda? I mean, not the baking soda, the baking powder. Better do it right. Baking soda was a good test. Baking powder reacted to the water and the acid. So it was not going to be a good test because if it would react with water and make us go, oh, water must be an acid. Well, no, we know better than that, right? So the baking powder, not such a good test for acid, right? Um, the other two were. So we saw a chemical reaction, which is what showed us that it reacted to the acid. So the baking soda reacted to the acid with the fizzing and bubbling. The purple liquid reacted with the acid, with turning it pink. The baking soda reacted to our baking powder reacted to the acid as well, but it also reacted to water. So it's just reactive and not a good test. All right. So we took that test a little further in our goo making. Okay. We were taking different liquids and powders, right, which are solid, and mixing them together to see if we found something different. And we got a lot of no reactions, remember, but the baking soda and ketchup fizzed up, okay, because there is acid, mild acid, right, in the ketchup. And then we got a little bit of reaction between the milk and the vinegar. Remember, it kind of curdled up. Um, so there was some reaction there. As a matter of fact, when milk is mixed with acids, it tends to sour and curdle and like that. But our big change, remember, the borax was that big change, and we were able to um, mix that up together and make our goo, right? So we had that chemical reaction, okay? Um, but again, nothing disappeared. Okay, all the ingredients were still in there. They just changed. Okay, so if you were going to make a cake and you grabbed a box of cake mix and you put in your oil and you put in your eggs and you put in your water, okay, and you mixed it all up and you stuck it in the oven and it baked up, so you added heat when you stuck it in the oven, okay, you are making a chemical reaction and it turns out delicious, right? um, you don't have, as a matter of fact, you can't look at your cake and try to pull back out the oil and pull back out the eggs and pull back out the water. You can't do that because it has made this change. Okay, this chemical change has happened. Um, and then in this final mystery, mystery five, where we made explosions. Okay, very mild explosions, but we did make it happen. So again, we went back to the baking soda and vinegar, and we got those mixed together. And remember, in all of our tests, we saw that fizzing and bubbling, and the alchemists were like going, wow, what happens to all those bubbles? What's going on here? Well, remember, nothing goes away entirely. What were those bubbles? What was happening? So we sealed it in a Ziploc bag, and remember, it blew up like a balloon. When we got enough of it, it blew up enough to pop the bag as well. But what was collecting in there? What were those bubbles? Okay, it turned into a gas, and we were able to contain the gas for a while in our plastic bag. And if it popped, then what do you think happened? Well, the gas escaped outside the hole. We're lucky we're not the alchemists. We weren't doing it with a glass flask. That would have been very dangerous and could be um, cut you up, get in your eyes, all that kind of stuff. So that's why we wouldn't use um, the glass for that. So just kind of remember that these particles, they don't disappear. Okay, they change, but they don't disappear. Okay, they make changes. So tomorrow or whenever it is you end up taking the test, um, it's going to talk again about all these kinds of things. They're going to talk about 3 lemonade stands where they were mixing sugar with lemon juice to make lemonade. And then they froze the lemon juice to make popsicles. So remember, use that knowledge you know about weight and about taste and all of that, because we've talked about that. Okay, they're going to talk again about using salt and vinegar and pennies, and about the weights, what's going to happen to the weight of the pennies, what's going to happen to the weight of the salt and vinegar. So remember, none of those particles totally disappear. They go from one place to the other place. They're too small for our eyes to see, but they don't just disappear. Okay, there's going to be a question about putting that um, baking soda and vinegar in the bag. What's going on in the bag, and so they're going to have you draw a picture about that. Okay, so just think about it. What is the salt, or what is the vinegar and baking soda making? Okay, what's going on inside that bag? Okay, they're going to talk about it. And then they're going to have you think about back to baking soda, salt, and baking powder. Baking soda reacted only with acid. Okay, salt doesn't react with either one of them. And baking powder reacts to both water and vinegar. So they'll explain it in the question, so you don't have to memorize that. But you have to come up with a way of testing each of these white things. Baking powder, baking soda, and salt are all white. So they're going to have you use what you know to come up with an experiment. Okay, how can you figure that out? And the final question, I'm curious to go check it out myself. It has to do with an experiment with things that we haven't totally worked with yet. The main ingredient being hydrogen peroxide. But it's like, what do you need to do to figure out whether there will be a reaction or not? So this test is going to be about you thinking about all those things that we've learned through these mysteries and in the videos. You have to remember what Doug has taught you, okay? And put that to good use when you take the test tomorrow, okay? When you take the test again, like before, if you can print it out, that's great. Print it out, fill it out, take a picture or scan it and send it to me in an email. If you can't print it out, then just write the answers. Just make sure you put a good number on them so I know what your answer is going to be. Okay, when it asks you to draw a picture, do the best that you can. When it asks you to maybe draw that, it'll have you drawing kind of a little graph. You can do the best you can. Okay, so just write it out on binder paper. Again, take a picture or a scan and send it in to me with an email. All right, if you have questions or problems, don't hesitate to shoot me an email. I am sure going to do fabulous. On Thursday, we're going to start history. I've got a series of YouTube videos, but I'm sending you another. You'll get another YouTube video of me explaining history a little bit more for you on Thursday. All right, miss you guys so much. This science unit has been fun. We'll see you later. Bye.